Respected Padmadanji, respected Professor Ashutosh Sharma, Professor Napati, Professor Anil Rajvanshi, Professor Shobha, and Professor Sumi Saxena, and ladies and gentlemen. I am delighted and honored to have been asked by our organizers to deliver a short inaugural address. For that, I must really thank Dr. Shobha Shukla, who has put her faith in a fossilized specimen like me. I did some work in developing innovative water technologies in my previous avatar as a water researcher during 70s and 80s. I am a very old person. I don't dye my hair, but I look about which I will talk in my institute lecture today now. And I hope some of you will be here to listen to that. Nowadays, I spend most of my time in understanding the nature of human mind. That is my latest avatar. Because I believe that if we develop a very powerful mind, then it will give us wisdom to use our natural resources wisely and can help us live a sustainable life. Water usage and its conservation are an important part of this strategy. This also follows my pet theme that spirituality plus technology is equal to sustainability and happiness, about which I have written for the last 20 years, and I have a couple of books on that. And I would urge some of you to look in the net because they are freely available. But we have gathered here to discuss water technology and not spirituality. And here are some of my thoughts on this important subject. Because this is a very vast subject. It touches us, all of us. And so I'll give a very overview, not the detailed one. Total projected water demand, according to the Government of India data, is around 810 billion cubic meter. Average rainfall over Indian landmass is around 3,880 billion cubic meter. So our water requirement is only 20% of the total rainfall that we get. Our rainfall is uneven and quite at times it does not fall where we need it. Thus there is a need to develop innovative water vapor management technology. Water vapor is the right word. If we can manage water vapor in whatever form, then we would have solved the problems of water in India. Rainwater harvesting, which is a part of water vapor management, should be done locally, and its judicious use is the only solution to India's water crisis. Water vapor management has three components, according to me: rainwater harvesting, cloud management, and dew condensation. They are all part of the vapor. I will briefly talk about them. In rainwater harvesting, construction of small rainwater harvesting ponds, which are interconnected, could provide a possible solution in rural areas. I come from rural Maharashtra. Maharashtra had a very fantastic example of digging up check dams, which help the water problems. Somehow lately, those check dams have not been dug up, and so we are having a lot of problems. These small water storage bodies will act similar to inverter battery backup for electric supply. I will talk about the strategy in my lecture later on, and very powerful AI systems can help in managing these bodies so that we can have year-round supply of water in rural areas. Soil excavated during the construction of these ponds can be used for making bricks and in other aspects of construction and agricultural industries. Today, most of the farmers, when they dig up the pond, they spread the soil on the fields. Naturally, the issue of ownership of these water bodies and the energy requirements will have to be evaluated thoroughly. There is a need, therefore, for setting up few experimental systems to validate this concept. In urban areas, rainwater harvesting in every building will help the process. It should be made mandatory and incorporated as a part of building code. The rainwater can be filtered and purified for various uses. Technologies exist for doing so. In our institute, we have developed a rainwater harvesting system with solar purification to provide clean drinking water for rural households. We are now extending it to provide clean drinking water for rural schools. In fact, the biggest problem in rural schools in India today is the lack of clean drinking water. And when the health of the children is not very good, you can imagine how much they can absorb. I will also talk about this in detail in my lecture. The second aspect of water management is cloud management. Since rain comes from the clouds, there is a need for cloud management. Solar energy has already evaporated water to form a cloud, and hence there is a need to manage it for water production wherever it is needed. This is far better than desalination, which requires a huge amount of energy to evaporate water. Cloud management presently is done in a limited manner via cloud seeding, but it is a dicey process since one is not sure where it will rain. I had a great honor of knowing and interacting with Vincent Schaefer, the father of cloud seeding. He was the assistant of Langmuir, who was the top scientist in General Electric. In fact, he was the first industrial chemist to get a Nobel Prize. And I interacted with Vincent Schaefer quite a lot. And he told me that science of cloud seeding is very dicey, and unfortunately till today, this situation has not improved. But it is very useful for a lot of politicians because they can spend a lot of money by going ahead with the cloud seeding. Nobody knows whether the rains come, so the money goes. We therefore dreamt of a scheme in early 1980s about using specially designed kites to suck the clouds and transport them to the ground through a hollow pipe, which would also act as a kite string. The water vapor could be condensed by a suitable means for water production, and it came out of my work on dew condensation. And the scheme, though, has remained as a dream. But I guess with better materials and drone technology, it should be possible to make small prototypes and test the idea. And I'm sure that some of the bright young engineers and researchers present here may take this as a challenge. Clouds consist of charged particles. Their water droplets are charged. We still do not know how the cloud droplets get charged. A lot of theories, but still it is up in the air. With varying magnetic field of the earth, the cloud movement also changes, resulting in rains falling at unpredictable places. The total amount of solar energy falling on the earth has remained constant. The amount of clouds formation has remained constant. It is where they fall has changed. And this is not only because of the, people talk about climate change is happening, but it's also happening because of the changes in the magnetic field of the earth. And this is something to be thought and looked carefully. Detailed understanding of cloud physics will help us predict climate changes and manage it for our benefit. I am sure there can be many more creative schemes for cloud management and should be a challenge for young researchers and water technologists present here. And finally, I come to my pet theme of dew condensation. Before the water is evaporated and it goes very high to form a cloud, it remains near the Earth's surface as dew. Most of it is near the coast, but it also exists in various proportions all over the landmass and is a function of atmospheric water vapor conditions. India's mainland is endowed with a very long coastline of around 5,500 kilometers. All the areas situated near this coastline can get clean drinking water through dew condensation. I am very happy to tell you that we pioneered dew condensation in 1980s. And my paper was probably the first paper on dew condensation, which was published in Journal of Desalination in 1980. It's still quoted. We first developed the thermodynamic data for dew condensation and then developed a scheme for large-scale dew collection for drinking water purposes in coastal areas. I will talk about this in detail in my talk in the afternoon. Our work and calculations show that the Indian coastline today has the potential of producing 40% of India's total drinking water demand. That's a huge amount of water that can be produced for drinking purposes, not for any other purpose. However, there is a need to develop economical and innovative dew harvest technologies. And dew also is a charged particle. And so, if you have dew harvesters which have certain charges of certain polarity, then they can attract the dew very nicely. Thus, I feel that the strategy for developing water technology should be based on the following water vapor management systems: decentralized rainwater harvesting and its usage for various purposes, development of innovative technologies for cloud management, and dew collection in coastal areas for drinking water production. All these strategies combined can substantially alleviate the water crisis for India. I hope there will be some opportunities to discuss them in this seminar. And thank you very much.